Hi. In this video, I'm going to show you how to find the equation of a perpendicular bisector of a line segment. I'll start off by reviewing what a perpendicular bisector is, and then I'll go through how to find the equation, and then I'll just give you a few sort of helpful hints to keep track of what you're doing as you're working. Okay, so this question asks us to find the equation of the perpendicular bisector of AB, with A being the point 4, 1, and B being the point -2, -3. Okay, so the two first things we have to do are take a really good look think about what a perpendicular bisector is, and then we have to draw a sketch. We should do both of those before we do anything else. Okay, so perpendicular means that this is going to be a line that meets the segment AB at a right angle. 90 degrees. And what do we know about the slopes of perpendicular bisectors, of perpendicular lines? So slope, it'll be the negative reciprocal of the slope of AB. Okay? Now bisector means it's a line that's going to cut our segment, but it means more than intersect. Intersect means that it meets, thus this line will meet our segment. But bisect means it cuts exactly in half. Okay, and so what that means is it goes through the midpoint of AB. Okay, so this is really important. The bisector goes through a midpoint of a segment. Otherwise, it's just a line that intersects. Okay, so that's the word. Those are the words. Now let's look at a diagram here so we have some idea of what we should expect, and then we'll go through all the calculations. Okay, so we have the point 4, 1. Let's put that looks like about here. A 4, 1. And B is -2, -3. So this is the line segment we have. So what we're going to do is we're going to find the midpoint of that segment, which just as an estimate looks about here. And then we're going to find the slope of this segment, and we're going to find the perpendicular line. So it should look something like that. Okay, so we have to find the slope in the midpoint of AB. We could do that in any order. I suppose I'll find the slope first. Okay, so lowercase m AB equals y2 minus y1 over x2 minus x1. Let me label these x1, y1, x2, y2. Okay, so we have -3, take away 1, over -2, take away 4, which is -4 over -6. Negative divided by negative is positive, so that's 2/3. Okay, so in black we have the slope of AB equals 2/3. And this looks reasonable. That's definitely a positive slope because it's going in this direction. And it looks a little bit less than a 45-degree angle with the horizontal. So that would mean it's a little bit less than 1, and 2/3 is. So that sounds good. Okay, so our slope is going to be perpendicular to that. So I like this abbreviation here, M with a perpendicular line, and you can just pronounce it M perp. So we need a negative reciprocal, so it's going to be -3 over 2. Okay, so now we know the slope of our line, and to find the equation we need to know the coordinates of at least one point on the line. And the only one really we can know without knowing anything else is this midpoint of AB. And that's again because it's a bisector, so it cuts exactly in the middle. Okay, so the midpoint, capital M, of AB is equal to So it's the average of the x's, x1 plus x2 over 2, and the average of the y's. So x1, 4 plus negative 2 over 2, comma, and now the average of the y's, 1 plus negative 3 over 2. So that's 4 plus negative 2, that's 2 over 2. 2 over 2. And then here we've got 1 plus negative 3, so that's negative 2 over 2. So this is equal to the point 1, negative 1. Okay, and before we go over any further, we go back to the sketch and say, does that make sense? If I'd estimated this, I would have maybe guessed 3/4, 3/4, 3/4, negative 3/4, because it on my little sketch it doesn't look quite at 1, negative 1, but it looks really close. So this is definitely good enough. If we had, say, our x value was negative 2, we'd know that that was way off. If the x value was 0, we might think, oh, that looks a bit far, and then we could do a more careful sketch. Okay, so that looks really close. So this is the point 1, negative 1. Okay, so now we know everything we need to find the equation of the perpendicular bisector. Let's write this down. So the perpendicular bisector has slope. Here was the slope of AB, and here's our perpendicular slope. Slope of up at m equals negative 3 over 2. That might be a bit redundant there, because we're writing slope and m. And a perpendicular bisector passes through the point this point here, at the midpoint of AB. So 1, negative 1. Okay, so we know a point in the slope, and that point doesn't happen to be the y-intercept, so I think the easiest thing to do now is to use the slope point form of the line. So y minus y1 equals m times x minus x1. And here's x1, y1. So we'll have y minus negative 1 equals our slope was negative 3 over 2 times x minus 1. So that's an equation of the line. It's a perfectly good equation of the line. That being said, people tend to prefer equations in slope intercept method, in slope intercept form. So I'm going to just simplify the right hand side here and isolate y. So here I have y plus 1 equals, so I'll expand this out. I have negative 3 over 2x, and then negative 3 over 2 times negative 1 will be plus 3 over 2, and then I'll just subtract 1 from both sides. So I have y equals negative 3 over 2x, and then plus 3 over 2 minus 1. If you're not sure about this, there's a few different ways of thinking about it. You can think, well, that's 1.5, take away 1. Or if you needed to, you could do it in your calculator. Or you could think of this 1 as 2 halves, so 3 halves minus 2 halves. But whichever way we think about it, we get plus a half. So that should be the answer there. Again, we shouldn't actually stop until we check and see if this is reasonable on our graph. So the way we check that is we check, does this line look like it has a slope of negative 3 over 2? That looks totally reasonable. It's a negative slope. It goes this way. Does the y-intercept look like it might be at 0, 1/2? And I think it does. It's this point right here. It looks just on this graph. It looks a tiny bit less than a half, but really, really close. So this looks totally reasonable. So this right here is the equation of the perpendicular bisector of AB. Okay, so just to review, if you need to find a perpendicular bisector of a segment, there's two things you need. You need the slope to be the negative reciprocal of the original slope. So that's what we calculated here, and then we flipped it to get the perpendicular slope. And you need your line to go through the midpoint. So that's the bisecting part, the midpoint of the original segment. So we've calculated the midpoint here, and so we've got that point there. And then you have the slope and a point, so you can use slope-point form. It's probably the easiest way to get the equation, not the only way. And then simplify until you get a slope-intersect method. All the way along, look at your sketch to make sure things are reasonable. I would also just strongly suggest that when you find something out, you write it in the appropriate place on your sketch, just because it helps you keep track of things. So for example, when I found out the slope of AB, I wrote it next to AB. When I found out my perpendicular slope, I wrote it next to my perpendicular line. When I found out the midpoint, I wrote it there. Just because there's a lot of different things going on in this question, and that kind of helps you keep track of everything. Okay, well, good luck with it.